All right, so let's continue with our lesson 3. We have example 1, and that is linear motion at catch-up point. These are cases which also set in linear motion. Okay, now we are having an example here. They're saying an overloaded taxi traveling at a constant speed. Note this word, constant speed. We say that at a constant speed, acceleration is always 0. In lesson 1, we explained that. Of 90 kilometers per hour, overtakes. The word overtakes, okay, overtakes, okay, a stationary police car, overtakes a stationary police car, a full stop. Now let's get a sketch in the first statement. They're saying an overloaded taxi traveling at a constant speed of 90 kilometers per hour overtakes the stationary police car, overtakes the stationary police car, meaning that if you have to draw, remember this motion is straight line. If we are to draw, say for example here, if we are to draw the sketch of this, so solution, the sketch of this will be like this. Whereby now, if we see an overloaded taxi is traveling at a constant speed of 9 kilometers per hour, overtakes a stationary police car. If it is the taxi has overtaken, it means that the taxi will be in front. The taxi will be in front there, and a police car will be behind it. Police car, because the taxi has overtaken, it is running in front. Overtake means, let's say for example, if this one is here and you are running like this, then here I'm overtaking in front. So it means that the taxi will be in front and the police car will be behind. Okay, maybe we start summarizing the same. And over the taxi is traveling at constant speed. That word constant speed implies that the acceleration is 0 meters per second squared. Please, you have to know that. Terminologies in mechanics make it a bit simple or hard. So you must be very keen. Okay. At a constant speed of 90 kilometers per hour, that's the initial velocity. So initial velocity is 90 kilometers per hour. 90 kilometers per hour. Of course, you know this must be converted. This 90 kilometers per hour must be converted into seconds, and we shall do that in time. Let's first of all complete the question. Okay. Overtakes a stationary. The word is stationary police car. Stationary means that it is starting from rest, or its initial velocity is 0. I've said stationary police car. Its initial velocity is 0. Okay, first stop, that's saying 2 seconds later, now this word here, 2 seconds later, 2 seconds later, comma, the police car sets off in pursuit of, pursuit means they are chasing at a high speed, sets off in pursuit of a taxi, accelerating at 6 meters per second squared. Accelerating at 6 meters per second squared. Now, the police car which is chasing in pursuit is then accelerating at this because we already have the acceleration for the taxi. So now the police car is done accelerating at this. So the acceleration of the taxi, rather the police car, is 6 meters per second squared. All the information has been covered. They're saying how far does the traffic car travel before catching up. At catch up point, meaning that as you are running like this, you are running, but then I come and I catch up with you. Like that. We shall be knowing or seeing what we really mean by that. Catch up is the same as overtaking. To overtake, means that you are caught up with someone. Like that. Or meeting a point. Don't use the word overtake, you can say meet at a point. All the same. Catch up, meet at a point, overtaking, all the same. Okay. Now, here, let's analyze this word 2 seconds later. Now, here, whenever they say this word here 2 seconds later, in simple terms, or the simple summary I can give you is you come and look at who is in front, the taxi one which is in front. Now, 2 seconds later means you're going to add a +2. So it means that if you say that their time, the time for this level time is equal to t. Even this one here, time is equal to t. Now, the one who is in front is the one who will take over this 2. You can say a +2, the one who is in front. But if you want to put that 2 on this one who is behind, then you say -2. Then you put a t. Here, t, if it's in front, you put a +2. Here, if you want to put there, you say -2, then here you maintain a t. Like what I'm meaning? If you want to do with this, you would have said t -2, then here t. all the same. If you want to be put behind, but in the front, you add a +2. That's how we analyze that word of 2 seconds later, because uh, we know that first body minus, okay, time by the second body minus time. Okay, maybe let's just leave it as that. This explanation is enough. All right, now that's the information we have. And what do they want? How far does the traffic car travel before catching up? Now, how far means the distance or displacement. Now, S, displacement covered by the police car, I would call it SP. We don't know it. And the displacement covered by the taxi ST, I will say we don't know it. But then what you must know is, you must now say that at catch up point, at catch up point, comma, the distance covered by the police car must be equal to the distance covered by the taxi. That's what I'm meaning. Like, say for example, I'll explain. If this is the lane, here is where the police car, and this is where the taxi is. They're all running. And maybe you realize that as they're all running like this will be the meeting point. If they run, like say for example, if they run, remember, if the police car is here, the taxi came, this was the taxi, came and bypassed it. Now the taxi is at that level. So it means that the taxi also has covered this distance here. So it means that even the police car will also start running, chasing, as this one is also continuing. If the police car comes at a high speed and they all meet at this level here like this, it means that they all met at this level. It means that the taxi has covered the distance from here up to here, as well as the police car has also covered the distance from here up to here. Because remember, this taxi before reaching here, it came and bypassed the stationary car, which was the police car. So it means that they will all have covered the same distance. So it means that at catch-up point, SP is equal to ST. The distance covered by the police car must be equal to the distance covered by the taxi. That's the logic at the catch-up point. And let's try to explain that. Okay. Now, let's proceed. Now, shall now say that. All right. So this will be SP will be equal to ST. But what is S? S is UT. We know that from S is UT plus a half AT squared. Second equation of motion, please. Now they come and substitute. Distance covered by the police car, we shall say S is equal to, what is the U? The U is 0. Okay, maybe I put it here for some people to see. I'm meaning UT plus a half AT squared must be equal to, I'm just putting for you to understand, UT plus, of course, ST, UT plus a half AT squared. But these details must be for the police car. So police car, we have initial velocity 0 times time, which is T, plus a half times acceleration, which is 6, times time, which is T squared. This must be equal to, all right, this must be equal to, okay, now the U for the taxi. Of course, this is 90 kilometers. To convert it, 90 kilometers per hour into meters per second. To convert it, you will just say 90 times 1,000 over 3,600. The answer you get there would be the one for that part. All right, so, and after converting that level, when your calculator, okay, press, this one will give us 25, I think. So I'll give us 25 meters per second. Please, I told you, don't allow these if the units are in kilometers per hour, always convert meters per second. So we have 25, so this will be a 25 plus a half times, now the acceleration at that level, it is starting from rest, rather moving at a constant speed. That acceleration is 0 times the T squared. Times the T squared, that will give us times the, oh, this is 25T. This is 25T, by the way, sorry. 25t, 25t, okay, 25t plus that times, okay, 25, sorry, this is 25 into t plus 2, by the way, plus a half times the acceleration is 0 times a t plus 2 but squared, but the 0 will kill each and everything there. So 0 times t will give us a 0 here, shall remain with a 3t squared. Why? This cancels. 3 times that will be 3t squared is equal to, multiply here, we shall get 25t plus 50t. I've expanded. All right, 25t plus 50t. All right, now we can now say we solve this. We solve now. This is the one for this police car, and this is the one for the taxi. ST means displacement covered by police car. ST means displacement covered by the taxi. Correct like terms. Like terms you have 3t squared minus 25t minus 25t minus 50t equals to 0. Bulldozer, please you go buy a bulldozer. T will be equal to negative, but 25 here plus or minus square root. Sorry, square root. So a negative 25 minus 4 into a is 3. Okay. C, that is 50 over a2 into 3. So here we need the time t. Time t, or another time will be that in seconds. In seconds, press your calculator and give us that answer. And for my calculators, we are getting 10 seconds and negative 1.6667. So t, from our calculator, we are getting 10 seconds and negative 1.6667. Please, time can never be negative. So we shall take time as a positive 10. Now to our question, we have gotten now the time. And how did we get the time? We have used the logic that at catch-up point, the distance covered by the two bodies must be equal. Now we said how far does the traffic car? So they want to know how far does the traffic car move. But distance covered by the traffic car is this. So now we shall say distance covered by the traffic car or the police car is equal to, okay, 3t squared after simplifying everything. 3t squared, which will, this one will be 3 into 10 squared. And now this will just be, okay, 300 meters. In simple terms, maybe I can just bring it here. What I'm meaning is that that will be, okay, it will be, SP will be equal to a 3 into 10 but squared. So SP will be equal to a 300 meters, as simple as that. That's what they required in that simple question. Okay, so we have another question, the last one. Okay, that was in up to 14, number 12. They're saying that the lorry starts from a point A and moves along a straight horizontal road with a constant acceleration of 2 meters per second squared. Please, the word constant acceleration means that you're going to use the other 3 equations of motion. The word constant acceleration only means that. Some people make a mistake that word constant acceleration, then they think about maybe velocity is 0. No, constant acceleration only means you're going to use the other 3 equations. Okay, constant acceleration of that. Then at the same time, a car moving with the speed of 20 meters per second and a constant acceleration of 3 meters per second squared is 400 meters behind the point A. Is 400 meters behind the point A. 400 meters behind point A. All right. And moving in the same direction as a lorry. So they're all moving in the same direction. Okay, good. Now let's start summarizing. So a lorry starts from point A. So meaning that, let's start solution. You follow the statements slow but sure. So we know that we are here. This point A. I said a lorry starts from point A and moves along a straight horizontal road. Maybe we're saying that the lorry is moving in that order, no problem. A straight horizontal road with a constant acceleration of that. So our lorry has an acceleration of 2 meters per second squared. This is our lorry, like that. Okay, and the lorry is moving in that order, that direction, that straight line. Okay, and at the same time, a car moving with a speed of 20 meters per second and a constant acceleration of 3 meters per second squared is 400 meters behind point A. Now, is 400 meters behind point A. Remember, you already have your point A from drawing. So, mean that the car is 400 meters behind point A. Mean that if the lorry is going in the other order, if the lorry is going in the other order, like that, I'll put it there. If the lorry is going in the other order, so I'll make it a bit thick, to be different, or to be unique up to that level. So, the lorry, this point A, but the car is 400 meters. 400 meters behind point A. So, mean that the car is here. That's the point where we have our car. Okay, and what was the details of the car? At the same time, a car moving with the speed of this. So the car is moving with the speed of 20 meters per second. Okay, and a constant acceleration of 3 meters per second, acceleration 3 meters per second squared. Okay, is moving in the same direction. So even the car is moving in that same direction there. Okay, in the same direction as the lorry. Find how far from A the car overtakes the lorry. Find how far from A the car overtakes the lorry. So just know that they are running. And if the car is chasing the lorry and they're all running, it means that it's very possible that these people will meet at this point of overtake. So they overtake from here. Overtake. Point of overtake is there. Whereby a lorry is coming, even the lorry is coming, and even the car is coming. As they move at high speed, they overtake from here to move. So, as simple as that. Now, but they want a distance. The distance from here up that point of overtaking. Do you even know it? No, we don't know. So that distance, you can call it x, because it's the one they want. We can call that distance x, as simple as that. Okay, then Roman number 2, the speed of the lorry when it is being overtaken. No problem. So let's start solving. Did we miss out any detail here? Okay, a lorry moves along that. Okay, now I think that we have not left out anything, but if you see here, a lorry starts from point A. Okay, do we miss out any word there? A lorry starts from point A and moves along a horizontal road with a constant that. So the lorry is just starting from point A. That implies that its initial velocity is 0. Starts from. It means that its initial velocity is 0. Here, the lorry is starting from, so that its initial velocity is 0. We have to put that into consideration. Okay, now we shall need to see the displacement covered by the car and even the displacement covered by the lorry. Please, SL means distance covered by the lorry, SC means distance covered by the car. We all don't know that. Okay, good. Now what we're going to do, the distance from here up to here is x. I've explained that. Now we shall say, first case, let's start with the car. From S is equal to UT plus a half AT squared. Will that equation work? Do we even have time for this? We have the time given to us there in the question. Do we have time? In the question? No, we don't have. So maybe that you just have to suffer locally. So therefore, I now say distance is equal to that. Now, what's the distance covered by the car? The car moved from here up the point where they will overtake. From here up to here, that will be 400 plus x. So that will mean that, SC, then SC is 400 plus x. The distance covered by this is from here up the point of attack, which is x. I'm sorry for that. Okay, good. Now let's substitute. This will now be 400 plus x is equal to, the initial velocity is 20 times t plus a half times acceleration is 3 times the time, which is time t squared. All right. So we proceed. This will now be, allow me start with this. Okay, it will be 400 plus x is equal to 20t plus, this will be 1.5t squared. If you divide 3 by this, then the t squared will remain there. This is now your equation number 1. The next, I've looked at car. Now let me look at a lorry. I want to look at lorry. And when I'm looking at lorry, I'll also use the same equation. S is equal to ut plus a half at but squared. Now, our S here is x equals to u. U is 0 times t. T we don't have. Okay. plus times the acceleration, which is 2, times the t, which is squared, like that. So our x here will be, in simple terms, when you cancel this, our x will just be equal to t squared, and this is now my equation 2 will be equal to c squared rather t squared. That's my equation number 2. Having done that, now let's solve 1 and 2. Please, you can also use the other logic of equating, whereby this one leave it as x, this one take this side and say that distance covered by this is equal to distance covered by this. Then you equate x equal to x. However, though you can also solve equation 1 and 2. Now we say put equation 1 into 2. That's what I'm doing. Put equation 1 into 2. Now that will be that a 4,000, that the 400 plus x is equal to 20t plus 1.5t squared. Now, my x is t squared. What I'm aiming for is to have a common value. So my x is t squared, so to be 400 plus t squared is equal to 20t plus 1.5t squared. So when I try to arrange, this will now be 1.5t squared plus 20t, I'm harmonizing, is equal to 400 plus t squared. I'm just harmonizing to make it in right order. So let all of them come this side. We shall have 1.5 t squared plus 20t minus 400 minus t squared is equal to 0. Now we find that 1.5 t squared minus this will give us a 0.5 t squared plus 20t minus 400 equals to 0. From there, please, you go straight away to bulldozer. So t will be equal to, all right, 20 negative plus or minus square root, again a 20. Please, I'm using bulldozer, which you must be knowing from your algebra, minus a 4 into a 0.5 into 400 negative 400, like that, but over, I'm using bulldozer to solve that quadratic equation, over 2 into a 0.5, like that. Now here it will give us your values of t. Here it will give us your values of t. Shall have the value of t there in seconds. Then you have t is also equal to some value there. When you press your calculator, okay, let's enter that in the calculator. Have this, that. So now the answers we have is 14.6, then negative 54.6. So t is equal to 14.6, okay, 4 dps, then negative 54.64, very soon here 64, and some other digits there. 4 decimal places, let me see, press the calculator. The first value is 14.6410. Okay, everything is 6410 for either side. Okay, can leave it as that. These are seconds. Now, we said time can never be negative. We take it as a positive answer. Then, if you are going to take t as a positive, then what do they want? In part A, they're saying, find how far from A the car overtakes the lorry. How far from A? They want that value of x. But the value of x can be got from this. X is equal to t squared. So I shall now say from x is equal to t squared. From x is equal to t squared, we shall now say x is now equal to 14.64 squared. What would be that x? That's the distance they want. And that was enough to give you your 10 marks. Simple mechanics. And now that one is going to be 214.3589. So it will be 214.4 meters. You can leave it as that. Or to make it clear for you, the answer, the value of x is 214.35. Let me see on the calculator. 3589 meters. 89 meters. As simple as that. Now what you are remaining with is this Roman number 2, where they're saying that the speed of the lorry when it is being overtaken the speed of the lorry when it's being overtaken. Let's look into that very fast also, and we get this done with the ease. We get this done with the ease. All right, so let's see the speed of the lorry when it's being overtaken. That will be, shall say, from speed of the lorry when it's being overtaken. That's the final velocity. That's now from, I will answer it from here. I will say now from V is equal to U plus AT. Now, the lorry when it's being overtaken, the initial velocity is 0. So V is equal to 0 plus the acceleration is 2 times, what's the time? The time has been 14.64, like that. Now what will be your final velocity there in meters per second? And with that, you'll have answered the question fully. And from a calculator, you press 0 plus 2 times 14.64, that will give us 29.28. That will give us 29.28 meters per second. As simple as that. Please don't forget to subscribe. Thank you.